Who remembers the test of symmetry for the y-axis? Anybody remember? What? I heard someone say it. Change the sign on x. So let's look at our equation. And we're going to change the sign on x. Now, if we change the sign on x, this is what our work would look like. And what happens when we square that? It stays the same. So what is the answer to the problem? Yes. There is symmetry to the y-axis, and therefore the curve is even. Or the function is the thing. It's not even a function, but it's even. Okay? The other question that might be asked is odd. What's the test of symmetry for odd? Origin, which means you change the sign on both. Hey, what if I change the sign on both in this problem? Would that still be okay? Yes. All right.
So can you just make it worse?
What?
So if you can do both, it'll be worse.
Yeah, when I ask the question, it'll probably be, is it even or is it odd?
And if it works, it's both.
Well, I'll only ask one question.
Okay.
Okay. But you would say both. Yeah.
Do we have a calculator?
I don't know. I don't think so. But let's see if we run into something where we need it. Okay, number 2. Identify with words or an equation. Uh-oh. We gotta know our BFFs, right? Which one is this? Square root of x. So, with an equation, it would be y equals the square root of x. Or you could write, it's the square root function, right? If you wanted to describe it with a name, words. Okay, Joe, you okay today?
Yeah, what?
I just wanted, I don't see a pencil moving there.
Oh, no, I was ready.
All right, name a BFF with this end behavior. Now, do not be confused. What this means is, as you go to the right, think about a graph, as you go to the right, this is positive infinity out here, the curve is going up. So, I don't know, something like that is happening. And then, as you go to the left, it's going down. So think of a BFF that has that behavior. It's down here and then it ends up here. Linear, cube, greatest integer, step, 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 step. But linear and cube are probably the most common ones.
Can we just put y equals x or y equals x?
Well, it does say name a BFF, but if you put, I'm so nice that if you put the equation, I would probably be okay with that.
Wait, so what?
It's, well, 2 of them, 3 of them would be linear, cubing, or greatest integer. Those are 3 I can think of off the top of my head.
On the quiz, do you want us to put like 1 over 3 or all?
It says name
Yeah.
A. All right, number 4. This is the one I think that's gonna give us problems if we're not careful. So let's look at number 4. Does anyone have an idea how we might start this problem? Factoring, absolutely. So how does the top factor?
X minus 5, X plus 1.
X minus 5, X plus 1. How about the bottom?
2, X minus 1, X plus 1.
Yeah, because when I take out a 2, I'm left with the difference of squares. Okay? All right, now, what do we notice about this? We have a hole. We can cancel. So I'm going to go ahead and cancel. And here is my new problem. And where will that hole be? The hole will be at -1 comma something. Now, how do I know that? Now, I set this grid up. You're not going to have to graph it, okay? You're not graphing it. But I put it so I can look at what's happening. So how do I know the hole's at -1? What did I cancel out?
X plus 1.
X plus 1, which means -1, right? If I had canceled this out, it would have been at +1. Okay? Now, the hole is a point. Hole is a point. X is -1 because of this. How do I find the y? Plug it back in right here. So -1 minus 5, 2 times -1 minus 1. So what is that? -6 over -4, which reduces to 3/2. So in the blank that says what's the whole, you're going to put -1 3/2. I'm going to go ahead and sketch it. You are not going to have to sketch it, but I want you to kind of see what's happening. You're going to have to fill in blanks just like you are here. All right, now tell me anything else you know. What? This is where you look now. Look here, right here.
Vertical is y equals 1.
Vertical is actually x equals 1. Now, if you get confused, go ahead and draw it, even though you're not going to have to. When you draw it, which axis do I cross? X. That's x equals 1. That line is x equals 1. All right, good. That's the vertical asymptote. Make a note if you're confused. Vertical asymptotes come from the denominator. The denominator. Vertical asymptotes, denominator. Okay? Horizontal is 1/2, Elijah says, because he's building this right here. He has 1x over 2x, so that is y equals 1/2. Beautiful, beautiful, beautiful. Okay. What do we mean by intercepts? Where we cross the axis. Now, just in general, guys, here's an x-intercept, right? I have no idea what that point is, but don't I know y has to be 0? So to find an x-intercept, you let y be 0. So in my equation, I'm going to take x minus 5 over 2x minus 1, and I'm going to set it equal to 0, because remember, that's y equals that. Are you keeping up with me? Okay. All right. Let's solve it. What happens when I multiply? It doesn't have to, if I multiply this over to here, isn't it just a line? So don't I just have this? Which means x equals, so my x-intercept, that's my x-intercept, is the 0.5 comma 0. Now what about a y-intercept? What do I know about a y-intercept? X is 0. X is 0. So I plug in 0. Back in here, let's see, if I plug in 0, I get -5 over 2 times -1. Did you get 5/2? what it would look like. Generally speaking, if you can get those 5 pieces of information that you just got, you can graph it. No, you don't have to graph it on the quiz. All right, so review. Vertical asymptotes come from the denominator. Horizontal asymptotes coming from boxing in the x's. Poles come from anything that cancels. To find an x-intercept, you let y be 0. And to find a y-intercept, you let x be 0. Now, for x-intercepts, when you let y be 0, you always end up with just the numerator. So you can also remember that x-intercepts come from the numerator, but you have only a certain amount of crap that you can remember, so that's just an additional thing. All right, you good? Jack, you okay, honey?
Yeah.
Okay. What's the domain? Tell me about the domain for problem A.
Bracket 3 is positive infinity.
Very good. We know where domain is concerned that whatever is under the radical has to be positive. So x has to be bigger than or equal to negative, or to 3, bigger than or equal to 3, which on the number line would look like this, which in interval notation, which is the way we're going to write it, looks like that. We good? Now the second one. Please don't cancel. Don't cancel. Remember, in a 3-part problem like this, if you're going to cancel, you got to be able to cancel all of them. You can't just cancel 2 of them. Okay? So tell me about domain. Everything except 0. One of your domain rules involves radicals. Whatever is under the radical has to be bigger than or equal to 0. The other domain rule says denominators cannot be 0. So if x can't be 0, then we got everything from negative infinity to 0, and then from 0 to infinity. That can be a little hard. I like to think of it as a picture. It's easier for me to write my interval when I think of that as a picture. We okay? All right, number 6, got a couple BFFs. We gotta sketch them. Anybody remember anything about your sine curve? Caitlin? Original sin. So right there we start the origin.
Hills and valleys.
Got a hill and a valley on both sides. Just like that. There you go. That's your sine curve.
Up to 1.
Up to, oh wow, you're on fire today. Good job. Up to 1 and down to negative 1.
Don't put the negative, -1 on the graph on the test.
Oh, it would be great if you did. I won't. But it would be great. I mean, it won't already be there. All right, what does x cubed look like? Anybody remember? X cubed also goes through the origin. And it goes like this till it gets to there. And then it goes like this. So Elijah says valley down, valley up. That's your x cubed. Now, do you think those will be exactly the 2 that are on the quiz?
Yeah, maybe.
Maybe, but probably not.
Yeah.
Right? We need to know our BFFs. All right. If we have time, we'll do a little quick review of that too. Consider this as drawn below. What's the domain?
All real.
Negative infinity to positive infinity. How do we know? Because domain is this way, x, and there's arrows going that way and an arrow going that way. So your domain is all real. Now, what about your range? That is not all real.
-2 to positive.
Bracket, -2, yeah, it goes up forever. All right, take a minute and digest that. Ronan, you're back there yawning. This making sense to you?
Yeah,
You're amazing.
What is intervals on which you
Who's talking to me?
me?
Yeah, what?
What does it mean by intervals on which you what does that mean?
Intervals on which it's increasing.
Yeah.
So look at the picture. Actually, trace over the picture. So start on the left and notice that your pencil's going down.
Oh, and
That's
then you take
decreasing.
and you take one to that.
Then it goes up. So from -3 to -1, we're increasing. Would you agree with that?
Bracket that?
-3, -1. No, let's use open intervals. Okay, now I want everybody listening to me. When I'm talking about increasing or decreasing, I'm talking about moving left to right. And if I'm moving left to right, then I'm talking about X's. Okay? So these are the X's where I'm going up. Now, are there any other X's where I'm going up?
-3 to infinity.
From 3 to infinity. These are both increasing intervals. Again, I'm looking at the X's. From here to here, I'm going up.
Can you union those?
You can, absolutely, you can union those.
Where'd you get -3? Right here. Is that, that's like, oh, wait. That isn't, oh, it's not.
No, this isn't an ordered pair, this is an interval.
Oh, okay.
This is the interval, from -3 to -1. From here to here, my pencil's going up.
Why is it not practiced?
Because at those endpoints, it really isn't going up or down. If you put brackets, I wouldn't mark it wrong, but typically they're open intervals. Okay, let's do, it's not on here, but let's do decreasing. Where is it decreasing?
0.
Negative
Negative infinity
From
to
negative
-3
infinity
to -3.
to -3. Where else?
0.
0 to
Zero.
-1 or to 1.
0 to 1, yep, 0 to 1. Yeah, you can union them or put commas between them, it doesn't matter. We're just listing the intervals. What's happening from 1 to 3?
Well, it's
Constant, not increasing or decreasing. All right, sketch. What shape
It's
is going to be a parabola?
It's gonna go up and then
And where is the vertex? Normally, it would be at the origin.
there's 0, they get -1.
Oh, no.
-1.
-1, -2.
Oh, I see that.
Why is the vertex at -1, -2? Because x plus 1 moves you left, and -2 moves you down 2. So you have this nice little parabola. Is this equation symmetric about the line y equals x? Okay. Another symmetry question. What is the test of symmetry for that? For y equals x. We switch the variables.
It's 4 minus 1.
What? We're testing for symmetry about the line y equals x. So I'm going to x equals negative y plus 4.
Would that be origin?
Origin is switch both sides.
Side
What?
Side
This is the identity, yep, yep. So we just replace the y's and x's. So I'm gonna go ahead and get y by itself. So can I add y to both sides? And then subtract x. So I have y equals 4 minus x. Is that the same as the original equation?
Yes.
It is. So the answer is, yeah, it is. It does have symmetry. Whatever your test is, you want to see if you end up with the same equation that you started with. Okay? We have 6 minutes till lunch. I will do more practice of any kind of problem you want.
You
Dana?
need this one again? Another one of these two.
Where we're testing for symmetry about the identity line? Okay. So let's consider the line, or the thing, x squared plus y squared minus 3x equals 5. And we want to know, does it have symmetry about the identity, y equals x? What's the test for symmetry about the identity? It's one of our special symmetries. Switch the variables, right? So this would be y squared plus x squared minus 3y equals 5. Does that match that?
No.
So this one would be a
No.
no.
Oh, no, thanks.
The other one we did was yes.
What did you do over here?
Why what?
How's the y or y not?
Okay, because when I switched the variables, I got the same equation.
Alright, so I just write down.
Yeah.
Okay, but I'm not following your steps over here. You go to that again.
So I switched the variables,
Oh, wait, then I see it.
which is the test. And then I solved for y, because I couldn't tell if those matched or not. So I got y by itself, and then I could see if
Yeah.
it matched.
Okay.
Can we do another one like 4?
4? Yep. Okay. 2x squared minus 2x minus 12 over x squared minus 6. All right, here we go. So we're gonna take this problem, and we're gonna find all the asymptotes, all the intercepts, and the holes. Okay? So how do we start? What do we do first? Factor everything. So let's see, if I take a 2 out of that. That's gonna be 2x minus 3x plus 2, is that right?
Yeah.
Over difference of squares, x plus 3, x minus 3.
Yeah.
Okay, so step 1, factor. Okay? Now, I notice I can cancel, which means I'm going to have a hole at the point where x
-3.
equals
Or 3.
3. Look at what I canceled. That means the hole is at 3. Then I'll plug that 3 in right here. So 2 times 5 over 6. 5 thirds. So that's where the hole is. Is that you okay there? Everybody good? All right, let's look at what we've got here then.
Horizontal.
Horizontal asymptote is going to be y equals 2. Everybody get that? Y equals 2. And then vertical is going to be x equals negative 3.
You only care about what's in the parentheses, or the horizontal asymptote. You don't care about
Horizontal asymptote is here. That's how we find the horizontal asymptote.
I mean, vertical.
Vertical is what's in the denominator. What makes it 0. Okay, now I need an x-intercept and a y-intercept. And you might, I I know you're not drawing this thing, but remind yourself an x-intercept is something comma 0. So if you set this equal to 0, and you multiply this over to here, it's still 0. Divide by 2, it's still 0. So what is x? Negative 2. So your x-intercept is negative 2, 0. And then your y-intercept is 0, comma. So we'll put 0 in and we get 4 over 3. Yep. Is that okay with everybody?
Yep.
Alright. Alright, I'll see you back at 45. Have a wonderful lunch. Oh no, when did that fall down? Oh no.